Hey everyone, this is Lakshya here. So today we're gonna start with our lead code question number 2095, which says delete the middle node of a linked list, which is a medium level question. So what it says, you are given the head of a linked list, delete the middle node and return the head of the modified linked list. The middle node of the linked list of size n is the n by 2 node from the start using zero-based indexing where x denotes the largest integer less than or equal to x. So basically in this question we have to delete the middle of the linked list. Means let's take the example. So let's take a shorter example. Suppose this is our linked list and we have to delete the middle of this linked list. So we know this is the middle, and to delete it our this pointer should be pointing to this location. So how we can do that? So to do this we will take two pointers. For that we will take three pointers. One is slow, another is fast, and one more pointer is previous. So with the help of slow and fast pointer we will detect our middle element, and with the help of previous pointer we will delete that element. Okay, so for this we will iterate our list till our fast will reach null or fast next will point to null. So at each step our slow will move to one step ahead and our fast will move to two step ahead, and our previous will be at slow's position. Then then on next iteration again our previous will move to slow's position, then our slow move to slow's next, and our fast move to fast next. Now we can see that fast next is pointing to null. That means here we stop our iteration and we can see our slow is pointing to the middle element. So now what we will do, our previous will point to slow's next. Means we will delete this pointer and our previous will point to slow's next, and we will then delete our slow, and hence we will return our head, which will be initially at here. So that's it. This is how we will get our desired linked list. Let's take the example which is given in the question only. Let's take here 1 3 4 7 1 2 6. So again we have head and previous. Initially our previous is null. Okay, previous is pointing to null, and a slow pointer and a fast pointer. So the first step is our previous will point to where our slow, means our previous will move to the position of our slow, means our previous will move here, then our slow will move to slow's next, and our fast will move to fast dot next, means here. Then on another iteration our previous will move to slow, our slow will move to one step ahead, and our fast will move to fast dot next. Then again on another iteration our previous will move here, our slow will move here, and our fast moves here. Now we can see our fast next is pointing to null. That means here we will stop our iteration, and we can see our slow is pointing to the middle element. See, you can count 3 this side, 3 this side. So our slow is pointing to this, and previous is pointing to a one element before the middle element. So now our previous pointer will point to slow's next, and we will simply delete our slow pointer and return our head from here. This is our head, we will return our head, and that's it. We will get our answer. So let's write down pseudocode. So let's consider some pointers. Slow, which will be pointing to head, fast, which will be pointing to head, and previous, which will be pointing to null. Sorry. Okay. So while our fast is not equals to null and fast next fast fast next is not equals to null, then we will move our previous to slow pointer, and our slow will be slows dot next, and our fast will be fast dot next dot next. After this, once we will traverse our whole linked list, then we will simply our previous next will point to slows next. This will delete our linked list, and for that, to remove that element, we will simply delete our slow, and then we will return our head. So that's it. This is our pseudocode. With the help of this, we can simply traverse our linked list. Now let's discuss the time complexity. So we can see that we are only traversing our list only one time here and nothing else. So the time complexity will be our most optimized, that is big of n. This is the best time complexity we can get. And the space complexity will be big of 1 because we are not using any another data structure, any external data structure to perform our operation. So that's it. That's our code. So you must try this yourself. Until or unless you face difficulty, I will provide us below our original code that you can run on LeetCode. So here it is our code. And one thing I forgot, that before doing anything you must check this condition also every time, that if our head is null or head next equals to null, that means we have either having no element or only just one element, like this means. So in that case we will not perform this task, we will simply return null. Otherwise we will do the same. Slow will point to head, fast will point to head, previous equals to null. Then these are our operations, and at last our previous next will point to slows next. Then we will delete our slow, and then we will return our head. So that's it. Thanks for watching. Bye bye.